In this session, we're going to cover some of the critical elements of an NFV SDN solution. We're going to tap our direct experience with the largest service providers and enterprises on the planet. We're going to give you the lessons they've learned in delivering this at scale from a cloud-managed platform. But before we do that, let's cover a couple simple terms. First of all, what is network functions virtualization? In NFV, network functions run as software modules on x86-based servers, so they'll consume compute, storage, and network resources on those servers. What does it provide? Well, it gives you the ability to have elastic services in which you can spin up and spin down networks much more simply. It decouples hardware from software, so it gives service providers especially, and large enterprises, more flexibility in certain cases. The goal for these is to automate everything and network operations, so you might have more agility to be able to spin up and down software processes representing your network functions. That's cool. And the goal of reducing OpEx is always there. But the issue that many of the service providers are having is how do they reduce complexity? If I wanted to spin up maybe 1,000 different branch sites running NFV functions, I need to have 1,000 different mini data centers with compute, network, and storage that I need to manage. So you have to be careful from an operations standpoint that you're not introducing complexity versus reducing complexity. Each NFV requires network compute and storage. Therefore, you need to be able to manage not just the NFV, but also the infrastructure it runs on. What is software-defined networking? Well, software-defined networking is an architecture in which the control and data planes are decoupled from each other. The network intelligence and states are centralized, typically resident in the cloud, and the underlying network infrastructure is abstracted from the applications. What does this all buy you? Well, first of all, it gives you a control plane that can run in the cloud and a forwarding plane that can run potentially at a lower cost on a device in a branch or campus or data center environment. It gives you a central management capability. So you have a global view of the world, and you can push a policy not just to a single platform, but to thousands of devices with a couple clicks. You'll see that today in our system. The goal of automating everything and simplifying operations is there, and we've actually achieved that. You're going to see how simple it is to push out policy to thousands of devices and onboard devices when you have a centralized control plane, which is pretty cool. You'll see that today in our demonstrations. The goal of reducing operational expenses is also there. You got to be careful here, just as we had with NFV. When you have independent control planes, then you have independent element managers. And when you're trying to roll out multiple services, each service can become a silo where you've got to do new work for every new service that you want to deploy. So the benefit of SDN is to have an external control plane resident in the cloud. One of the downsides that you'll see coming up is that each independent SDN controller is an independent silo that needs to be managed. No worries, we'll show you how we can overcome that with MSX. So, what are the service providers telling us in terms of the disruptive technologies that are unlocking these new services? SPs today are focused on number one, simplified operations. We got to do more with less. Number two, we've got to deliver not a single service, but many managed services. And number three, we need a drastic improvement in time to market. So how are they achieving this? First of all, service orchestration. Everybody knows that. It's an efficiency that you're going to derive from automation of your processes, self-service fulfillment, and what you're trying to achieve is more of a DevOps model. Number two, network functions virtualization. We've already talked about this. It's the flexibility to transform your network solutions to virtual appliances to help reduce some of your operational expense. Number three, cloud native. It's an agile service delivery model built on microservices, containers, scalable cloud management. These play together significantly with SDN and NFV. We'll show you that in a minute. And then number four, software-defined networking, as we spoke about. It allows you to more dynamically bring services to market and deliver a broader range of services to your customers than you can achieve today. The convergence of these multiple disruptive technologies has created a massive opportunity. MSX, Managed Service Accelerator, has allowed service providers to take advantage of these disruptive technologies to deliver managed services much more simply. So we've created a checklist for choosing managed service platforms. MSX, Managed Service Accelerator, checks every box on this list. I'll go through this very quickly, but you can come back and take a look at it. So what do SPs mean by service orchestration? They mean efficiency through automation. You need to be able to orchestrate both physical and virtual platforms, and it needs to have Cisco and third parties available for the catalog. You need to be able to represent things in models like Yang. You need to be able to connect to those devices through confd, CLI, network element drivers, and the orchestration platform needs sophisticated services like rollback. In case a mistake is made through the automation, it rolls back to the previous configuration. CSV files for bulk provisioning, and the scale that they're looking to deploy at is hundreds of thousands of devices. Network functions virtualization. What do SPs mean by this? Well, they want to be able to have capability to have lifecycle management and service orchestration for the VNF. It's not just about deploying one VNF. It's about managing it over the lifecycle. Those VNFs need to be able to run in clouds or x86-based devices. We'll show you both of those today. You need to be able to manage not just the provisioning of it, but the smart licensing and the pricing models that go along with it. And if possible, you need to be able to certify both Cisco and third-party VNFs on your platform. MSX does all of these. Cloud native. It gives you agility from a service delivery standpoint. We'll show you that today. We'll talk about microservices, containers, geo-redundancy, but what they're really allowing you to do is take advantage of cloud to deliver web scale and multi-tenancy for thousands of sites and hundreds of tenants all at the same time. You can run in any cloud, both public or private, and you need to have a self-service sort of nature. So you need to be able to offer service catalogs, monetize those, and integrate with third-party tooling. And then finally, what do they mean by software-defined networking? It means that you're going to have these external controllers in the cloud, and you're going to have APIs to those cloud controllers so that you can manage your services. You're going to have centralized device management, role-based access, interface with your OSS and BSS. You need to be able to not only take from the services that are offered, but create new services, including analytics and monitoring. And then you need to be able to provide this in a multi-tenant framework in which each tenant's data is securely encrypted. We're going to show you how MSX checks every box on this list. The Managed Service Accelerator architecture is cloud native. It interfaces northbound with OSS and BSS systems, and it interfaces southbound with different cloud-based management controllers, as well as automation and analytics. MSX is also cloud native. What is cloud native? Well, cloud native is an approach where the way you build and run applications exploit the advantages of cloud computing models. So what does that mean? Well, first of all, applications in the cloud platform are containerized. Each application and process is packaged in its own container. This allows you to run these applications on a range of different platforms very simply. Secondly, dynamically orchestrated. Containers can be actively scheduled and managed to optimize resource utilization. So you're going to see things like chaos monkeys flying around, killing containers on purpose, having things spun up, or the elastic capacity of containers to be able to spin them up based on demand. So containers in a cloud-native environment can be dynamically orchestrated. And then finally, microservices oriented. Rather than having these big, long, monolithic applications in a microservice framework are segmented into microservices. This significantly increases your overall agility and the ability to maintain applications over time. So we want an agile DevOps model. We want a more rapid time to market. We need microservices that adapt to not only APIs, but also a better structure for growth and agility as you move forward. And then we need the portability to be able to run these services on not a public cloud, but also private clouds and other compute models very simply. What are containers? Containers provide an agility and Vim independence. So containers isolate and abstract resources. So all of your applications can run in a container, and a container can run multiple applications in a single VM. This helps to maximize utilization without the overhead of replicating the OS for every single VM. It's a more efficient model and a more portable model that allows you to do things much more efficiently in a cloud-native network. And finally, the last component that our service providers are demanding is to make sure that whatever you propose as an orchestration platform or NFV services runs in an ETSI NFV framework. So this is the overall infrastructure that you guys are familiar with. MSX supports that infrastructure, where MSX provides both the customer and operator-facing resources. The NFVO, which helps manage the life cycle of network services, is called NSO, Cisco Network Services Orchestrator. The VNFM, the functions manager to do the lifecycle management of VNFs, is Cisco's Elastic Services Controller, and we run on a bunch of different VIMs. One example of that is the Cisco VIM, which is the infrastructure that we run on for both OpenStack and other services. So we've covered the critical elements of an NFV solution. These are the elements that service providers and large enterprises require to be able to manage their networks at scale.